All right, good afternoon, everybody. So, luck-driven development. I'm Ronnie Chen, a data engineer at Slack, and we're going to talk about building for serendipity. Now, first, I have a confession to make. We all know that luck plays a factor in our line of work. We make these far-reaching decisions based on little more than a hunch. A stray conversation can lead to a technical breakthrough, and a string of bad luck can sink the project that you spent your last 2 years building. But it's something that can be a little uncomfortable to think about too much, because if we really believe that luck plays a significant role in success, it's really tempting to just stop trying. In fact, when I was first brainstorming a talk about what we built at Slack Data, it was really hard to shake the feeling that we didn't have anything good to talk about, because the most interesting projects were the result of luck, and that didn't seem like a very good story to get on stage and share. But the more that I ruminated over that fact, the more I realized that luck is the story that I wanted to talk about. When I joined Slack in 2016, we had 5 data engineers on the team, and we were supporting a company of over 350 employees. The data warehouse was just getting off the ground, and a lot of key data questions were answered by querying production directly. We're talking about the real infancy of the data infrastructure at Slack. We were hiring data analysts a lot faster than we were hiring data engineers, and hiring engineers in general faster than we were hiring data engineers. So jump to today. Not only do we have a lot more analysts, but 1 in 9 Slack employees use the data warehouse every single day, and 1 in 3 Slack employees use the data warehouse at least once a week. So that first year, data engineering at Slack looked an awful lot like this. And any fumble on our parts means that the train goes off the tracks. And it took a lot of hard work, some good timing, and a whole lot of luck to get to where we are today. So that luck is what we're going to talk about. We're going to talk about recognizing and fostering luck, taking advantage of luck, building resiliency to bad luck, saving your luck for when you need it, and Slack Data's lucky break. So let's get started. Whether you call it luck, or chance, or randomness, there's this element of chaos that exists in our day-to-day lives. And all of this chaos grants us opportunities to take a different path. Sometimes that's an easier path, or a more productive path. Professor Richard Wiseman has spent over a decade studying the principles of luck. And his first principle to creating good luck is to maximize the opportunities for chance to happen so that you can notice and act on these lucky breaks. And this isn't a really novel concept. People even went to the effort of attributing this quote to an ancient Roman philosopher just to lend it some credibility. It says, "Luck is what happens when preparation meets opportunity." Being prepared to capitalize on luck when it appears is a cornerstone of success, along with intelligence and hard work. Before you can seize that moment, you have to recognize when it appears. And there's another Seneca quote, a real one that he actually said, and it goes like this: "If one does not know to which port one is sailing, no wind is favorable." If you don't know where you're trying to go, nothing is lucky. A crucial part of being able to leverage good fortune is the ability to identify it when it first appears. And in this letter that Seneca writes, the best part is actually the sentence that comes before. And it says, "Our plans miscarry because they have no aim." Our plans miscarry because we have no aim. And if one does not know which port one is sailing to, no wind is favorable. When it comes to project planning, a really common thing to do is to set your aim on what you want to do. I mean, it almost sounds idiotic to say it out loud. Obviously, when we make plans, we talk about what we plan to do. But there's a subtlety here that makes it really easy for us to develop tunnel vision about our work. So instead of focusing on what you want to do, set your aim on what you want to accomplish. Because goals that you set that are tied to a very specific action are very limiting. And while you do want goals that are precise, you want them to shift as your circumstances shift. The ecosystem of tech, and especially for data, changes so quickly that by the time a ticket makes it out of your backlog, that technology can be outdated or deprecated or just not a good fit for your requirements. You never want to spend months or even years with your head down, building something, just to realize after you ship that you built the wrong thing. If you focus on what you want to accomplish, the reason, the thing that you're trying to achieve, you're much more likely to be on the lookout for all of the ways that you can make that happen. And so instead of that tunnel vision, you're looking for all the different patterns and paths that you can take to achieve your goal. And you're primed to look for the best path to do that. This is an example of a goal that is focused on the how. Build a new service for running large queries using some new technology. And reading this, we don't even know what problem we're trying to solve. But this is something that you see a lot in a Jira backlog, in a quarterly goal. And we can infer by reading this that something about our current implementation isn't working. But that context is lost. We just know we want to build a thing, and we've forgotten the why. Here's a better goal. Make querying the data warehouse reliable and performant, even for large data sets. And then we can break that down into more specific goals, goals that we can measure, goals that we can evaluate, and goals that don't dictate how we do it. We can only measure whether or not we achieve it. And this way, we can evaluate whether our proposed plan fits the definition of success that we want. Maybe we want to support queries with billions of rows. Maybe we want 95% of our typical queries to run in under 20 seconds, or 99%. Maybe we want data to show up in our data warehouse within 5 minutes of being written. Each of those is a goal that is measurable and quantifiable, but does not dictate how you're going to do it. So as context changes, as circumstances change, as technology changes, we can achieve this in the best way in the moment. And we can triage the things that prevent this from being the case. Maybe you don't need to build a brand new thing after all. Maybe the reason so many queries are failing is because your analysts are not writing the best queries that they have the ability to write. Maybe they need more information about your system. Maybe there's a specific pain point that you can address. So all of these things can lead you towards the best way to achieve the things that you actually need to do by maintaining context on what you actually need. Without that context, you can't tell a lucky break from a detour. By focusing on what you need, it's easier to make sure that what you're doing is the right thing to do. You get to validate those assumptions sooner, you get to shed the cruft sooner, and you get to pivot sooner. It allows you to recognize those favorable wins. Your goals can move as your environment moves. So you know where you're going to go and build your goals around that. And you can recognize what is pushing you along that path and what is pulling you away from that destination. So let's talk about the next step, which is taking advantage of luck when it appears. Have you ever had a lucky break that turned out really disappointing because for whatever reason it just didn't work out? The timing is all wrong. Something else got in the way. And all that hope and excitement and joy just evaporates. Bad luck. Just wasn't meant to be. How do you fix a problem like bad timing? We do that by changing how we work so that we can adapt to the environment more easily. Incremental development, so that we can pivot when we need to. A lot of times our instinct when we're breaking down large projects is to just divide up the tasks. This is our project, this is piece 1, piece 2, piece 3, and we just break it up. The problem with that is that most of the time, you don't have a working project until everything is done. If your needs change, if your technology changes, you're stuck. You either have to scrap everything that you've done and start over from scratch, or stick with what you have, knowing that there's another road not taken. And that means that a lot of lucky breaks just pass you by. Here's another fake quote with a really good point to make. If I had asked people what they wanted, they would have said faster horses. By supposedly Henry Ford. Human brains are really vulnerable to a lot of biases. There's anchoring bias, where you rely too much on previous decisions and previous status to make your new decisions. There's a sunk cost fallacy, where you double down on the costs you've already incurred and focus on the past as opposed to the future. The best way to break free of that is to give people something new, a prototype to interact with, something that can give you actionable feedback. If you start iterating on the smallest unit of concrete value that you can provide, you can refine and develop from there. This is an excellent drawing by Henrik Nyberg that really captures the essence of adaptable, incremental development. In the first row, we take our project and we just break it down into pieces. And maybe you have a progress meter, you have something that you can put into Jira, but first of all, you've bought yourself in, you know exactly what the end project is going to be, and you don't have a tool that anybody can use until you have a working car. Your customers are not happy with just a tire. Your customers are not happy with a set of tires and an axle. They're not happy because they don't have anything that they can use until the very end. In the second row, you have that same context, but every iteration produces something that fulfills the underlying need that you have. And the benefit here is that every time you ship, you're learning about what you can do and what your customers need. Your customers are providing feedback to you at every single stage of this iteration, and you can gradually add complexity to enhance the usability. So instead of thinking about MVP, the way that you want to think about this is building the earliest testable product, the earliest usable product, and then finally getting to the earliest lovable product. And you get so much useful feedback here about what you actually need that you can maintain some flexibility in your development process to take advantage of that luck. If you find the right opportunity on another project, you can leave your users with a motorcycle and know that they can still go where they need to go. You have time to put out another fire or shift your focus, but you can ship something that they can use. Maybe you find out that you don't even need a car. Maybe you find out that for a long time, you can achieve most of what you need with just the scooter. Especially when you're on a small team, a very lean team, that's under a lot of time pressure, this kind of development really gives you the flexibility to focus your attention where you need it the most. Another thing that you want to do when you have a product development cycle like this is shielding the complexity behind a curtain that your users never have to look behind. Having a well-defined interface gives you the ability to shift components as you need to, while still maintaining a seamless experience for your end users. You can retool underlying technology, and your users can be completely oblivious to the fact that the mechanics have changed. They don't need to know what size the engine is. They just need to get in the car and trust that it will take them where they want to go. And so you want to build this interface so that your users have a consistent experience that allows you to tinker behind the hood, behind that shield, and upgrade as you need to. Building resiliency to bad luck. You're going to get it wrong at some point. Every single engineer has this dream of a greenfield project where you fix all of the mistakes that you made in your last project. As far as I know, nobody has ever gotten one exactly right. Maybe next time. But in a field like data engineering, the mistakes that you make can survive to haunt you forever. And so there's a tendency to focus on fixing everything and making it perfect because you know it's going to live in that data warehouse and follow you forever and ever. But just as we get accustomed to spurts of good luck, we have to anticipate there's going to be unlucky times. And the thing to do there is to take that hit and keep going. When you're running a skeleton crew of data engineers, trying to build and scale a platform out of whole cloth, you don't really have the luxury of taking your time. So, you might get love for it, you might get hate for it, but you're going to get nothing if you wait for it. So, you want to fail fast. Failing fast lets you try out an idea, figure out what doesn't work, and still have the time and energy to keep going. If you didn't know, the story of Slack is actually the story of a game company that didn't succeed, which became a workplace communication tool that did. And even before that, there was another game company that did not succeed, and an image hosting company that did. That was Flickr. So failing fast gives you the chance to pivot and turn failures into a different kind of success. So recognizing when something isn't working is its own kind of luck, and failing fast gives you the time to turn that into something else. Another really important thing is to recognize when not quite right is good enough. Do what you need to do and move on to the next problem. As much as this picture stresses me out, I know that there are similar hacks lurking in our data warehouse. And if you are all honest with yourselves, I think that you'll find that you probably do as well. Because getting key functionality shipped and moving on is a much smarter use of your resources than knocking down everything to satisfy your inner perfectionist. Remember the context around what you're doing. Remember where you're aiming. Learning to be okay with good enough and keep pushing on the bigger projects is the key to retaining your sanity. Because the luck that we're talking about, the luck that you have in your team, that only lasts until your people's energy runs out. Your resilience is directly tied to the reserves of your team. So learn to save your energy reserves and save your luck. Finally, saving your luck for a rainy day. One of the best ways to save your luck is to make it hard to do the wrong thing. Now, that's why I'm a big fan of things like structured data and typed data. Those are the things that kind of contribute to the daily accumulation of luck so that you can fill up that luck jar. But for big projects with lots of moving parts, the really painful deploys, there is one pattern that we really like to use a lot at Slack Data. And I'm talking about testing on production. Now, having a development environment is great, but there's no way to predict the full range of behaviors and problems that can occur on a system without really using that system. The entire infrastructure is too complex. Your test data, your test scenarios, they're never going to fully replicate all of the ways that things can go wrong in real life. So when it really, really has to work, you test on prod. And so I'm going to tell you the power of the dark side. Now, remember I said that this section was about saving your luck. And testing on production is the riskiest thing you can possibly do. But it doesn't have to be, because I'm kind of cheating a little bit. I'm talking about dark reads. One of the earliest data challenges that the engineering team had to face was when we had to move a pipeline in our product that was running on queries against the production database. Over 40% of the load on our prod DB was from running these queries. And obviously, we needed to move this off. This predated the formation of the data engineering team, and we did not like that there was so much load on production. But we needed to know that our replacement worked as intended and that our replacement could handle the load. And so dark reads is our way of validating our assumptions. If you've ever taken a look at the analytics page on your Slack team, this is the product of that work. We were able to move team stats out of querying on production and into a much more stable product that is the output of the data warehouse. As a result of doing that, we were also able to enhance the product itself and make it a much richer product for our consumers. Remember I said that this was 40% of the load on our production databases. Thanks to implementing dark reads, this migration was a one-woman project executed by my teammate Diana. Every single time a request came in, we would send one to our news service that was an H-filed back key value store using Quiver, which is a product that came out of Foursquare. So we just had two systems running, and as we were doing this rollout, all of our requests would be fulfilled by the production database. But in the meantime, we are validating our assumptions, we are validating our data, and we are validating that our system can handle the load of production. We monitored the system, and we started scaling up the requests until we hit full production load. And we were testing with actual production volume, actual production queries, without disrupting the experience for our end users. And only once we were confident that everything was working and that the data from these dark reads was correct, did we switch over. And we could do that with confidence without worrying that we were breaking everything. And all of this leads me to my final segment, Slack's lucky break. This is where every single component that I've talked to you about comes together. Now, throughout this conference, people are talking about Spark and R and Scala and a little bit of Python. So you might be a little surprised to hear me say that Slack Data's biggest break is actually all thanks to PHP. It's true. Now, you may not know this, but the Slack app is built on PHP. And whatever your personal thoughts on it are, I'm guessing that you did not expect it to make an appearance in a data engineering talk. I certainly didn't. But in our data warehouse, we run our interactive queries on Presto. That's our tool to explore our data sets, to run ad hoc queries, to really play with our data. Anything that's not a large time series or a batch job goes into Presto. But unfortunately, we didn't have a good solution for using the output of that data for visualizations and dashboards. One key feature that was missing was the ability to include selectors in our dashboards. And so our analysts were having a really hard time making the kind of interactive dashboards that we wanted to build. So out of this frustration, our analytics engineering team sat down to create a solution. And this is Yongxing and Chris Peterson from Slack. And in a period of 2 days, they created a site out of PHP that allowed you to make a request to a Presto server, collect that data, and make a graph out of it. So that's it, Presto visualizations. They focused on making it extremely easy to do this one thing, and it addressed a really pressing pain point. And so it took very little time, literally 2 days, to get off the ground. And the adoption rate was very high because it solved a problem that we did not have a solution for. And so everybody who wanted to see a graph, who wanted to see a chart, who wanted to create a dashboard, started using this product. And immediately, people started making feature requests. Hey, I'd like to adjust the scale on this axis. I'd like to add a label. And this tool started to acquire more and more features. So what started as a way to build a kind of dashboard that we needed grew until it had the full feature set that we needed from a web UI. And at that point, it took over as the primary portal to interactive queries and data visualization at Slack. That's where everybody went to look at data for Slack. And so that made it a perfect interface. And we realized that we had the opportunity to fully control how queries were executed. When it came time to start tinkering with our data infrastructure, we realized that we could deploy an entire shadow cluster on which we can run a dark query of every single query that went to production. It gave us a complete simulation of our production cluster. Every configuration setting, every version upgrade, every library, every UDF, every bug fix, we can test on a production environment without affecting our users. And we can track all kinds of meaningful metrics out of that. As data people, A/B tests and experiments are our reason for existing. But how often do you do that on your own platform to evaluate your own product? This was fusing the idea of dark reads and A/B testing to take the pain out of our infrastructure development. We could roll out a new service, we could evaluate its performance, we can track query success rates, query times, cluster resource usage, we can triage a regression, all of this on production without breaking production. We got to be data-driven ourselves. We were able to really take down our cluster failure rate by deploying bug fixes and config changes by testing on a shadow cluster running directly against production. When we originally planned to improve the stability of our Presto clusters, our plan involved creating a set of golden queries to deploy so that we could make unit tests, creating a way to simulate cluster load, all of these things that would approximate what it would like to be in production. But once we realized that we could build a shadow cluster, we could do the same goal by just logging and comparing how it works. And that was just the first way that we use the Explorer tool. There's actually a lot more that we can do. Because we have control over the entire interface, we have the ability to shape the world behind it, to reshape it to what we need. As new technologies come out, as we want to play with new tools, we could do that. All of our dreams were possible. Do you want real-time data, streaming ingest? Let's build a streaming pipeline together with Kafka, Samza, and Druid. And we can put this interface at the front of it. And if you want access to our streaming data, you go to the exact same site that you did before. And let's put a UI in front of that so that none of your analysts and engineers have to learn a new query language. Just click from a drop-down menu, drag and drop. That's something that we're building right now. The Presto team at Facebook released a connector that they deemed extremely experimental called Raptor, which stores columnar data on the Presto nodes themselves in a format that is optimized for Presto queries. We're currently testing this as a way to do more robust caching for frequently queried tables, and we're examining its viability for more real-time work. But it comes with a lot of questions. Can it keep up with our current load? What configurations are best? What limitations does it have? Well, we've started evaluating it on a trial basis by throwing it into a production environment on our shadow cluster. Again, all of our operational complexity hidden behind the Explorer tool. The last time I gave a talk about Slack data, it was subtitled "A Series of Unfortunate Events." And this time I'm talking about luck. Because the idea to me of being able to upgrade versions and evaluate it in a production environment, the ability to safely deploy with confidence, that just makes me so happy. We roll it out to a shadow cluster, we check to see what breaks, we deploy fixes, and we promote when we know it's safe. It's so simple and life-changing, I could honestly cry. As data engineers, we join to do the fun stuff, the big stuff. Big data, scaling problems, large infrastructure issues. But a lot of times, the things that we're focused on are the little things. Version incompatibilities, libraries, regressions. And so we have this tool that allowed us to fix all of those things, to reduce the pain out of all of it. And it happened because someone else built a tool to solve a specific pain point, and we were lucky enough to be able to jump on board their skateboard. So the thought that I'd like to leave you with today is this. Luck is real, and the effects of luck are undeniable. But while we cannot influence our fortunes exactly, we can change how we're prepared for it and how we take advantage of it. A colleague of mine insists that everything I've talked about today is not luck at all. To him, it's more like optimizing outcomes and managing uncertainty in stochastic systems. And maybe if I give this talk again, I'll take his suggestion and update the title. But really, I think that this is just a different way of saying that good luck is a terrible thing to waste. And I hope that today I've given you some takeaways to help make sure that when an opportunity comes along, you will have the means to take advantage of that favorable wind. And so I hope that you all find your luck dragon today.
Thank you, Ronnie. Thank you, that's great. Okay, so we have some questions for you. So it's like glasses or to not glasses, that is the question. Right, so first question. What do data engineers at Slack exactly work on? Can you mention project examples?
So the data engineering team now is actually split into two different teams. And one team works on infrastructure, stability, expansion, performance. And so the things that I talked about, such as making Presto clusters more reliable, adding in an entire system to do real-time streaming, all of these infrastructure projects are on the purview of the core data engineering team. And the other half of the team is what we call product data engineers. And they're working on pipelines that do, to take in the data that we produce, to refine it, analyze it, and produce the core tables that are going to be used by our analysts.
Okay, so what are your daily warehouse users? So should I say, who are your daily what? It's like I've made them some sort of inanimate object or something. Okay, so who are your daily data warehouse users? Data scientists or people from any background or job title?
Like I mentioned before, 1 in 3 people in the company, not just engineering, in the company as a whole, use the data warehouse in any given week. So in the broad view of things, it's everybody. Specifically, we have a team of about 20 analysts that work on answering a variety of specific questions. And we have a data science team based in New York that is working on doing things like recommendations, highlights, optimizing search. And we also have people from various departments for engineering trying to solve questions about performance, about reliability. And we also have people who want to understand from a marketing perspective and a finance perspective. At the end of the day, the data warehouse provides core information about things like annual revenue and user research and user activation levels, all kinds of really key metrics for the business. So when the data warehouse goes down, when the dashboarding tools go down, we get comments and complaints from the board themselves and from the CEO.
Okay.
Like those are our shareholders all the way to the top.
Right. Okay, great. So what was the biggest challenge in building out data? Oh, it moved. Oh, somebody changed it. Where's my Slack person? Different, my Slido person. Okay, don't worry. Okay, so why don't you just use an already written data visualization tool? What are the benefits of doing it in-house?
So when we originally started doing this, we did not have a goal of doing everything in-house. We had a very specific need of certain kinds of dashboards and certain functionality that was missing from already created tools that were available for purchase. And so we were trying to solve, as I said, one very, very specific problem. And we just wanted to take away that pain point. And as soon as we got users, they wanted more. And it was never, I think, intended or envisioned to grow into this thing. That was the product of a lot of luck, a lot of insight into where it would go, and of us sort of jumping onto that bandwagon once we saw that it was becoming an essential part. But it was literally a 2-day project to solve one specific thing, right. And then once it was successful, then we started contributing more resources to it.
Like it just took off.
It took off on its own, exactly.
Okay.
In much the same way that Slack was originally not its own product, it was just a piece of Glitch, which was a gaming company. This tool was just a small component that took on a life of its own.
Okay, great. So, what was the biggest challenge in building out data infra for Slack?
The hardest thing was that really that initial animation that I showed where you're on the train and building out the railroad tracks in front of you. We started with such a lean team, and I joined at a time when Slack already needed so much data, and they needed analysis, and there was no infrastructure for it. And so we needed to be able to build out the tooling and have that scale up as Slack itself was exploding in popularity. And so it needed to work right from the first time. It needed to be answering questions, and we needed to be building and putting out fires and expanding the capabilities of the infrastructure and trying to just like lay out what we were doing tomorrow, today.
Right.
And so it was constantly this game of just frenzied laying out the railroad tracks.
Okay. So for our last question, we have got, so we've just asked that one. So the last question we're going to ask is this one by Joe King. There's been a lot of buzz around deep data lately. Is that something you're using at Slack? I actually would like some clarification if Joe King is here on what
you mean by deep data. Are you here?
Are you here, Joe King? Are you in the audience? Are you able to give us a little bit more clarity? Hello,
All
Joe?
right.
No?
Maybe not.
No, a little shy? Okay, so what we'll do is we'll ask one more question.
Okay.
So, which is the next one, which is how many hours do you spend on Slack per day? And why 8 like all of us?
I spend an unreasonable amount of time on Slack. Ever since I joined Slack, I don't actually read emails anymore, and I don't use emails anymore. Most of my communication is on Slack. And when I first started at Slack, they actually gave us onboarding on how to best use Slack in the way that we use it in the company. And so it's really become like my right hand in terms of keeping information, retaining information, searching information. I'm on, I think, 10 different Slack teams at the moment, various subgroups, friend groups, social teams, and work-related. And I think all of the Slack employees are Slack power users compared to the rest of the population. And the Slack power users within Slack are several orders of magnitude. They just live and breathe Slack all day long.
Slack all day long.
Absolutely.
Okay, wonderful. Thank you so much for being here. We have a gift for you. I'll show you all.
Thank you very
Okay.
much.
So thank you so much. Thank you for sharing the knowledge and the data. And have a wonderful conference.
Thank you.
Thanks a lot. Let's give her a warm clap.